Today we are going to start another interesting concept in mathematics, of which, irrespective of the fact that it is simple, most students are still finding it very difficult. But here in Waec, we are going to make such difficult tasks to become as simple as possible. So going to what sequence and series actually mean. Sequence is the succession of terms in such a way that the terms are related to one another according to a well-defined rule, while series on the other hand is the addition of the terms in a sequence. I want you to take note that I made mention of well-defined rule. Okay, so therefore the rule that pertains or that works for a particular sequence may not work for another sequence because of the set well-defined rule that each sequence needs to follow. Is that okay? Let us consider a particular example. Now, if we are told that the first three terms of a sequence is shown below, the first three terms of the sequence is 5, 11, and 17, where the set rule or the rule guiding this particular sequence is to multiply the set of positive integers by 6 and subtract by 1. So the well-defined rule that pertains to this particular sequence is that we have to multiply the set of positive integers by 6 and then subtract by 1. If you do that, the first positive integer we're going to consider is 1, 2, and 3. Let's just stop at 3 because we're told that we are considering the first three terms of the sequence. Is that okay? Now, based on this rule, which says we have to multiply the set of positive integers by 6 and then subtract by 1, we have that 1 times 6 minus 1 is the first one, which is 6 minus 1. Of course, this is 5. Okay? 2 times 6 minus 1 is 12 minus 1, which is 11. Is that okay? And then 3 multiplied by 6 minus 1 is equal to 18 minus 1, which equals to 17. That is why we have the sequence to be 5, 11, 17. And this dot, dot, dot means it is continuous. So we can decide to find for the first 20 terms of the particular sequence. Is that okay? And this is just to illustrate the fact that sequence actually follows a particular well-defined rule for us to be able to adequately explain how the sequence is. Is that okay? Now, let us consider another example. Let's say we have the sequence 1, 3, 9, 27, and 81. And the well-defined rule that governs this is 3 raised to power n minus 1. Okay, this is the rule that governs this. You realize that the rule that governs this particular sequence is actually different from the rule that governs this sequence. Is that okay? Now, if that is the case, let us check for this, where n is the number of terms. How many terms do we have here? We have 1, 2, 3, 4, and 5. We have 5 terms in this sequence. Now, when n equals 1, we have 3 into 1 minus 1, which is 3 raised to power 0. Anything raised to power 0 is 1. You realize that this is the same thing as this. Okay? Now let us consider the other one. When n is equal to 2, what happens? We have 3 into 2 minus 1, which is 3 raised to power 1. Of course, this is 3. You still realize that it is the same thing. Let us try for when n equals 3, we have 3 raised to power 3 minus 1, which is 3 raised to power of 2, and 3 raised to power of 2 is equal to 9. So when n is equal to 4, we have 3 raised to power 4 minus 1, which is 3 raised to power 3. This is 27. Okay? When n equals 5, we have 3 raised to power 5 minus 1, which is 3 raised to power 4. And 3 raised to power 4 is 81. Realize that all these are still the same thing. That means this particular law or this particular rule that the sequence follows is actually correct. Is that okay? So this is how we can illustrate or describe what sequence is. But series, on the other hand, like I said, I pointed out that series is the addition of the terms in the sequence. So we can make these, let's take this for example. To put it down in series form, we have 1 plus 3 plus 9 plus 27 plus 81 plus dot dot dot. So this is the series denotation or representation of the sequence that we have over here. We can do the same thing for these over here, and it is simply 5 plus 11 plus 17. This is actually the major difference between series and sequence, and this lecture is just like an introductory aspect or introduction to sequence and series is. In our next class, we are going to start our discussion using some examples or solving some examples to adequately illustrate what sequence is and what series is all about. If you have questions, kindly drop them on the platform, as I will always be there to attend to all your worries. Till we meet again. Bye.